Okay, so what order should this be in? Normally, you do the stuff on the inside first. That's what I recommend anyway. And in there, what you normally would do is multiply before subtract, so you do the opposite of that. You want to do the stuff in the opposite of normal order. So that should go first. So it's right 9. Secondly, you do the 4, which is 4, not 4 times wider, 1/4 as wide. If you said a shrink with a factor of 4, that would have been the same thing. Third thing, go out here, 2 times taller. And last is down 8. All right, I think you're going to need to keep those in mind of what order to do stuff in. All right, any questions on those? I think I did one wrong. Tell me. Don't just look at me funny, because I can't tell if that's just a normal look or if you have a question. All right. Why is vertex form so nice? Because it tells you the vertex, and like right now, I know where that parabola starts. Where? 3, 5. The vertex is 3, 5. If you don't see that by now, you're behind, because that's the vertex. Vertex is 3, 5 over 3 up 5. There it is. And now, is this a right side up or an upside down parabola? Right side up, because there's not negative in front. So it looks like that. I missed it, but I was close. And it also tells you the axis of symmetry. This line right here that runs down right down the middle of the parabola, that is not just 3. Some kids are going to write that in the test, and I will cry and mark it wrong, because then they're probably going to have to do a retake, which causes all this pain and suffering for both of us. And if they would have just wrote x equals 3, I'd be able to give them the full credit. Don't forget the x equals part, okay? All right. Next thing. We can rearrange things into vertex form with completing the square. That's the plus box, minus box thing I showed you the other day. I'm going to have you do an easy one to start with. Warm up your brain on this one. X squared plus 16x minus 3. And tell me what that one would be if you put it into vertex form. It'll really help you when you're asked, what's the highest that the ball ever went? That's the vertex. What's the lowest that the hole was? If it was a parabolic hole dug in the dirt by some crazy mathematical rabbit. The lowest it ever went? Well, that'd be the vertex. So that's the context. That's what makes it like an R3 level question, is to say, you know, like, why would you want a vertex? Well, it's the lowest or the highest spot. What's the maximum profit of the business? Oh, I'm talking about the vertex. So then you know, okay, if I want the vertex, I complete the square to get the vertex. So you go like this. Then you go like this. Are you with me so far? Okay, next step, you take half and then squared. Half of it, 16 is 8, 8 squared is 64. Then you write 2 sets of parentheses that need to be identical. That's the point. They are a perfect square. And you take the square root of the 64, make it 8 and 8. Why? Because when I FOIL this out, my firsts, outside, inside, and lasts, my lasts have to equal 64 when I multiply them. All right. And then this is minus 67. Final answer, y equals x plus 8 quantity squared minus 67. So if the question had been, what is the highest that the ball went, or no, what's the lowest that the submarine went? If your answer is your vertex this, which of these two is the time and which is the depth? This is the x, this is the y. Time is always the x. Now I know that means that time is negative in this case. We'll just ignore that for this particular example. And the negative 67 must mean it went down 67 feet under the water, was the lowest it went. Okay. Moving on. Oh wait, you know what? We got to do more complicated completing the square. That's one of the main things I got to teach you today. What happens if you're supposed to complete the square, but it starts like this? Write this one down. Put a star by it. This one's worthy of your full brain power. You need to know how to do advanced completing the square. So you still do plus box, minus box. You still put parentheses right here. But, and it's a big but, so to speak, you have to get the 2 out of there. Do you know why? Because if I'm ever going to make this into two things that are identical, if I put 2x and 2x, that's not going to work, is it? Because 2x times 2x is not 2x squared. It's 4x squared. And I can't put x and x here. Remember, they have to be identical, because that would make x squared, not 2x squared. So I have to get the 2 off of there. How am I going to do that? You're right, factor it out. The 2 comes out, and then I have x squared, but can I just take it out of just that? No, I got to take it out of the other stuff. Plus 2 comes out of the 20, what do you got left? 10x, and don't mess with the box. You can't take a 2 out of the box. You don't know what the box is. Leave it as just the box. It's a placeholder. And then a minus box. And then a minus 17. Now let's do half and square, and then I'm going to show you one more thing that's really easy to forget. Half of the 10 is, now notice I didn't do the half and square when it was a 20. I wait till I factor the 2 out. Now I do half and square. Half of the 10's 5. 5 squared, 25. 25. But now here's a really easy part to forget. Do you see how this 2, if I multiplied it in, would end up multiplying this box by 2, and I would end up with 2 times 25 makes 50? This box over here is supposed to be canceling that other box out. That's what its job is. So whatever you factor out here, you also have to multiply the other box by that number. So whatever's here, also put it here. Very easy to forget that. It also will give you a totally different answer if you don't do that. You need to have that. So now, two sets of parentheses, and then the negative 25 times 2 is negative 50 minus 17, and then this is x, and plus, and the square root of 25 is 5, and the final answer then, y equals 2x plus 5 squared minus 67. All right, so that's a little tougher completing the square. Last kind I got to show you is completing the square with a fraction. Why would you ever have a fraction in it? Like, what if it's something like this? X squared minus 3x plus 2. And I want to make that a perfect square so that I can get it into vertex form so that I can know the vertex. Write this one down. Also worthy of your full brain power. You've got to be able to handle fractions in these. So the first step, still the plus box, minus box. You always do that whenever you want vertex form. The only thing that's ugly here is that when I do half and square, half of negative 3 is negative 1.5, but then you'd have to square that, and it gets all nasty without a calculator. So here's a good solution. If I said half of 3, of means times, do you get that that would be the same as 3 over 2? Half of 3 is 3 over 2. Dividing something by 2 cuts it in half, right? So 3 over 2 is half of 3. But that's just half of 3. And what am I supposed to have? Half and square. Half and square. So I got to square that now. In fact, on that left side, I think I'm going to actually multiply it out. Because 3 over 2 squared, what if I were to write 9 over 4? It's the same thing. It'll be a little better. X, and where it was where it was plus and plus before, now it has to be minus and minus, because we need this middle term to come out to negative 3. And now the fraction ones are also tough to figure out what to put here. It's the square root of whatever was there. Well, that's 3 over 2 squared. What's the square root of 3 over 2 squared? 3 over 2. And there's no, thank you for thinking absolute value, but that's if there's a variable. There's no variable here, so it's just plain old 3 over 2. And then the last part, can I add these together unless they have a common denominator? No, I can't. So I need that 2 to change into how many fourths? 8 fourths. I just changed 2 into 8 fourths. And now I can actually put those together. And the final answer is y equals x minus 3 halves, quantity squared. And put those two together, a negative 1/4. And my answer for my vertex is 3 over 2, comma, negative 1/4. In the context of a problem where there's like a little mini submarine that's diving, at what time did it reach its lowest point? Which of these two is time? Yeah. At what time did it reach its lowest point? 1.5 minutes, or 1.5 seconds. 3 over 2, the same thing as 1.5. What was the lowest that the submarine ever went? Went down 1/4 of an inch on the little scale model or whatever. Okay? All right. That was the hardcore vertex form stuff. This is nice, easy R2 type question. They give you a couple points. You got to be able to make point slope. Would you, from memory, please write out the equation? Y minus y sub 1 is how it starts. What is it? M. Yep. All right, now, right away, I know I've been given 2 points. 1, negative 9, and 2, negative 11. I need to start by finding this. What's that called? The slope. I want you to calculate the slope quick. It's a nice, simple number if you do it right. If you don't know how to do the slope, you can't even do an R2 question. You get them, comes out to negative 2. Raise your hand if you got that right. Good. You could have got goofed up by those negatives real easy. All right, so slope's negative 2, so I could put a negative 2 right there. And then I put the point right there and there. Which point should I pick? You can pick either one you want. I'd pick the one of the smaller, easier numbers, which is probably this one. So I'm going to say x is 1. Y is negative 9. Y minus negative 9 equals negative 2. X minus 1, and there it is. And it's ugly. The only thing I would have changed is I'd make the 2 minuses into a plus. But leave it that way. Don't think you have to always solve for y. You don't. All right. Now, just like this one, you remember how we started here? We started with this formula you had to have memorized. If you didn't know that formula, it'd be really tough to do this. I'm about to show you one more of those formulas. And it's for doing a quadratic one, just like you used for point slope, except it's for quadratics. So please, put a star by this one. Y equals a, parentheses, x minus h squared plus k. Now, what goes where? Does it look kind of like vertex form? It should. That's the vertex right there. So if you give you a vertex, they have to give you a vertex, in fact, or you can't do this. If they give you a vertex and one other point, just like if I give you 2 points, you can find the equation for a line. On a quadratic, you got to give me the vertex and any other point. If you give me the vertex, like this one here, is at 5, 2, I can stick it in. And then the other point goes here and here. Again, on your notes, other, hopefully you can write better than me, point. The other point goes in there. And if you stick in the numbers in the right spots, all you'll have left is an A. Then you solve for the A, and you get the A alone. Why? Because then what you're finding is the stretch factor. Now just look at this blue one. Can you tell ahead of time that the stretch factor here is going to be negative because it's been flipped? Can you also see that this is that same blue parabola we used before, and you remember what stretch factor was? 2. So it's negative 2. I'll tell you that A is going to come out to negative 2. But I want to show you that even if the numbers were really weird, you could figure it out this way. If you can't see what the stretch factor is by looking, this is how you figure out the stretch factor with this neato little formula. All right, so now I'm going to actually put things in. 5, 2 goes in here. 5 goes here. Second, I'm going to do, that's a 5. This is a 2. That was the vertex. Now, what other point should we pick? Don't care. Any point will work. Okay. Use that point. So if I stick in a 4 for x, comma, 0 for y. Now, if I just solve this little equation, let's just do it quick. 4 minus 5 is what? Negative 1. Negative 1 squared is 1. So it's 1a plus 2 is equal to 0. I'm going to write that. 0 equals a plus 2. Do you get that a has to be negative 2? Subtract 2 from both sides. Negative 2 equals a. I'm telling you, there could be complicated ones that you would not be able to do just by looking at them. But you would be able to do by taking the vertex and any other point and sticking them into this equation. You solve it down, now you know what A is. So then, if you know what A is, now you should be able to write me the equation for that blue parabola. Y equals, go ahead, try it. The equation for that. Use vertex. What is the equation for this blue parabola? Well, I know vertex form. And the vertex was 5, 2. What's wrong with that? Why can't I just do that? Exactly. And what was the stretch and flip thing? And where should it go? In front of it, you're right. So I'm going to put the negative 2 right. Ooh, that was weird. Just thought I was erasing. There. Ooh, not there, actually. There. I'm writing. I wanted to write in blue. I'm so confused. There. There! Okay. So, from memory, write me the new equation for the day. I just gave it to you. Don't look at your paper. Starts with y equals. What's the first letter? A. Next part? X minus h squared plus k. This part is the vertex. This part is any other point. When you solve it, you'll know A, which is the stretch factor, which will tell you the final answer. So you can say, let's say I figure out the stretch factor is 3. I can say 3x minus, and I already must have known the vertex, and I could put it in right here and say the vertex is like 9 comma 7. There we go. That's how your final answer would look. You can't, this is the hard part to find though, and this is how you find it. Just like these problems where we give you 2 points, now we'll be giving you 2 points, except one's a vertex and one's some other point, and you'll be able to make me a quadratic formula for it. All right. I think we've covered everything that you need to know.